Hello. For today's brain teaser, we're going to take a look at a fractal and see if we can discern a pattern for how to predict the area left as we cut out pieces of it. So here's the scenario. At stage 0, we have the full square sheet of paper and it has an area of 1. At stage 1, we're going to cut out a square that's exactly in the center and whose side length is a third of the side length of the original square. At stage 2, we are going to surround the square we've got with new squares, each of which are a third of the side length of that square, and so on and so forth. So at stage 3, we would surround each of these squares with squares that are a third of their side length. And so the question is, could we easily predict what area would be left uncut out at, say, stage 25 without doing all of them? All right, so let's take a look then. So if we go back to our stage 0, and we said that it has an area of 1, then that means that since it's a square, each of these side lengths are 1. And so we would say that the area at square 0 is 1, and that the side length also equals 1. Now, at stage 1, we said that this side length is a third of the original side length. So that means that at stage 1, our side length 1 is 1/3. So to calculate the area at stage 1, we would take the area at stage 0, which was 1, and subtract from it the area we cut out, which is 1/3 squared, which is 1/9, which is 8/9. So the area at stage 1 is 8/9. Now, if we move over to stage 2, we know that the side length of those little guys is 1/3 of the side length at stage 1. So that means that the side length at stage 2 is 1/9. So now as we go to calculate our area of stage 2, we take the area that we had at stage 1, which was 8/9, and we subtract from it the area of our new cutout squares. Now there are 8 of them, so we're subtracting 8 times 1/9 squared, and so that is 8/81, and 8/9 minus 8/81 is 64/81. Now that should look a little bit familiar. 64, that's a perfect square, that's 8 squared. 81, that's a perfect square, that's 9 squared. So we could rewrite area of stage 2 as 8/9 squared. And now we're beginning to detect a pattern. Area at stage 1 is 8/9. Area at stage 2 is 8/9 squared. Let's check it out and see whether area at stage 3 is 8/9 to the third. So I'm not going to attempt to draw this, but let's just think through the math on this. So let's start with the side length at stage 3. Well, we know that it's a third of the previous one, so that makes it 1/27. And then we know that the area is our previous area minus 8 times 8 times 1/27 squared. Okay, where do I get that? Well, each of these 8 squares will now be surrounded by 8 more squares. So we will have 8 8s. And 1/27 squared, because the area of each squared will be the side length squared. So if I simplify that, so 8 times 8, that's 8 squared. And I'm going to rewrite 27 as a bunch of 3s. So that's 3 times 3 times 3. So as I apply that squared to it, that rewrites as 8 squared, that's our 8 times 8, and our 3 times 3 times 3, that's 3 to the third, raised to the second is 3 to the sixth. So I have 8 squared over 3 to the sixth. Well, 3 to the sixth can be rewritten as 9 to the third. So now I have 8 over 9 squared minus 8 squared over 9 to the third. Well, let's rewrite that as top and bottom. So that becomes 8 squared over 9 squared. Now to do this subtraction, I need to take my 9 squared and turn it into 9 to the third. So I'm going to multiply top and bottom by 9. So that's 9 8 squareds over 9 to the third minus 8 squared over 9 to the third. Well, 9 8 squareds minus an 8 squared leaves us with 8 8 squareds over 9 to the third. And 8 times 8 squared is 8 to the third. So our area at stage 3 is in fact 8/9 to the third. And so you can see that we could do that out each time, and we would wind up that at the stage we were at, the amount of area that remained would be 8/9 to the whatever number stage we're at. So our final formula for this particular problem is A at stage n, the area at stage n is 8/9 raised to the n. And if you want to see how this maps onto the geometric sequence formula, let's take a look at that. So that says that the area at term n is the area at the first term times r, which is the common ratio, what you're multiplying each term by to get to the next, times the term minus 1. Well, let's put in our numbers. At stage 1, our area was 8/9. Our common multiple, what we're multiplying each by to get to the next term, is also 8/9. So if we have 8/9 times 8/9 to the n minus 1, well, a power written to subtraction is the same thing as division, so we could rewrite that like this. So that would be the same as 8/9 to the n divided by 8/9, and those two 8/9s will cancel, and so you can see we've got a to the n equals 8/9 to the n, whether we look at it through geometric sequence and series, or whether we look at it through trial and error and developing our pattern. And that is our Brainteaser fractal for the day. All right, go have a great day and keep on mathing.